just testing how it is works. So thank you for all coming and for being here. So my name is António. I'm going to talk about stable cell lines for antibody production and also for discovery. So as you already know, the company has a main goal to be able to provide all the service that clients need along their pipeline. So we started by having antibody discovery followed by antibody engineering. Then we added the protein production and biophysical characterization. And very recently this year, a new division was created that has a responsibility of making cell line development. So the cell line development will main focus on two branches. So the first one will be research related, so be able to generate tools that can support antibody discovery projects. The second one will be to generate stable cell lines that be able to produce your lead candidate antibody that you can further take on for other CMC projects. So I will talk about a little bit of each one of these branches and how the procedure is being set up at this moment at the company. And we hope that in the future they can be used by you as a service and included in your pipeline. So moving on to the stable cell lines for discovery. So the idea is to be able to generate stable cell lines that express the antigen. So then you can use them for several processes in the discovery, namely, for example, for immunization, selection and screening, or even characterization that can help you to find the right antibody at this stage. Regarding the workflow that we intend to have, so we have the vector construction where we have in-house the PCDNA 3.1 mammalian expression, and we will clone your genes of interest in this vector, but we can also use vectors that you have or others that you need. Regarding the cell lines that we have available at home, it's CHOK1 and HEC293 that are the most used in our projects, but we also can use the ones that you prefer. Then the idea is to transfect the cells using the electroporation method to achieve high efficiency, and then select these cells based on a selecting agent. Then we'll characterize the pool generation to see if they are expressing the antigen of the interest, and we can further move on to single clone if that's your needs, or we can select the pools according to the expression level that they want, or according to your needs for further discovery projects. In the end, we can deliver to you the cell line for your own purpose, or we can use it on the service for the different tasks that we have defined during the work package. So the other part of the cell line development is related to the ability to generate a stable cell line that is able to produce the antibody lead candidates. The idea is to have a single cell derived clone that can produce high and consistent levels of the antibody, and then this production can be supported for animal studies in early PD or PK non-GMP conditions. So for this, the platform that we are setting up in the company is a platform that is licensed from Merck Sigma with the chosen cells. Here you have like an overview of the characteristics. So they can be used for monoclonal antibodies, bispecifics, or Fc fusion productions. He has relatively short timelines for the research cell bank formation, so 16 to 18 weeks. The average yield of the clones that we get from there is from 4 to 8 grams per liter, and with a high stability of 16 generations. Most important is a well-validated platform with more than 100 molecules in phase 1 to 3 of clinical trials, and several already approved in the market. As a vector, we will use a single vector that has some optimized sequence that allow high integration efficiency and faster selection pools, and I'll go more in detail on that on the next slides. And the selection system will be based on the glutamine synthase because the cells are GS knockout, and I'll also explain a little bit more in the next slides. So regarding the show cells that are in the platform, so they are originated from the European collections for CHOK1 properties. They are GMP manufactured, fully viral tested, completely traceability, so they are regulatory friendly. They are adapted to grow in suspension in chemical defined and animal component-free media. and they are deleted for the gene of glutamine synthetase. So basically, the glutamine synthetase is the enzyme that is responsible for converting glutamate and ammonia and glutamine, that is an essential amino acid for the growth of the cells. And the way we select the cells, stable clones, is by transfecting these cells with a vector that contains the glutamine synthetase and also the genes of interest of the antibody, and grow them in media without glutamine. So this means that only the cells that integrate stable the plasmid and are able to synthesize the glutamine will be able to survive. So in this way, we will do the metabolic selections without addition of any inhibitors or any antibiotics. Regarding the vector that we will use, so this vector contains the DNA sequence that are called ubiquitins chromatin opening elements. So basically, they are DNA sequence that are methylation-free. So they are derived from housekeeping genes that are involved to prevent the silencing of linked genes and maintain the consistent transcription. So the vector by itself has two different OCE elements. One is located in the upstream light chain expression cassette, and the other is located between the heavy and the light chain expression cassette. And ideally, it will sustain expression and stably high gene maintenance. Data that is come from Merck show us that when they use a control vector or a vector that contains this DNA sequence for generating a cell line for a monoclonal antibody, throughout the process, they always see higher number of producing clones when they use the OCOA vector. And this will allow us to reduce the number of pools and clones to secrete, and also to significantly reduce the timelines to get your cell line. So here we have an overview of the process for the ones that are not familiarized with this kind of workflow. So we have 4 blocks. The first one is the pool generations. The second one, single cells cloning. The third, characterization of the cell banking, and the fourth, stability assessments. So we will start by cloning in the vector that I mentioned, your genes of interest of the antibody, and then we will transfect the cells by electroporation. Then we will grow these cells in media without glutamine so that we can select the clones that are stable. And then we will assess these pools, not only at the level of the IgG production, but also at the level of the specificity. So to see that you really are producing the antibody that binds to your target, but also, like Teresa mentioned, we also do biophysical characterization so that we are sure that the molecule has the right properties. Once we have the pools, we can then move on to single-cell monoclonality. So at this point, we are looking to several different equipments that allow you to see the one cell per well, and also imaging so that you can have a full report of monoclonality assurance that you can further take ahead for IND reports in the future. And once you have the single clones available, we will test them for the productivity and select the ones that are best, not only in terms of production, but also in terms of a comprehensive QC that is made to ensure, once again, that they have the right properties. After selecting the clones, then we'll move on to research cell banking, where they will be expanded. The clones will also be testing at the functional level to ensure, once again, that they are able to bind to the target or do what they should do. And after it, we can do the stability assessment, where the cells are going through 60 to 9 passage, and we will quantify the productivity in terms of IgG, but also cell viability and cell growth. So here we have, for the 3 blocks, pool generation, single cell cloning, and characterization cell bank, the type of assays that we will do for the characterization. Like Teresa mentioned, it's very important to confirm that already in this stage, you already have everything that you need in terms of molecule characterization so that we are safe for proceeding in each step. In the first step, we can go from specificity binding assays for ELISA, for example, but also a level of size and purity assessment for HPL. Then once we proceed and becomes more specific, we start to increase the type of assays, namely going, for example, for charge heterogeneity and also confirmation by max spec. And if it's important in your case for the antibody, looking to the glycan profiling. In the third phase, where we do the research bank, where you must be sure that the clones that you are picking are the ones that then will be reinforced for example, generation of master cell banks or even production of the protein or antigen that you need for your assays. Then we will do the functional characterization assays regarding to the functionality and specificity, but also several biophysical analytics characterization, namely also from the one that I referred before. We will test the banking for biosafety, so advantages, mycoplasma, sterility, and fungal, and we also evaluated the copy number of the gene that was integrated. So with this slide here, the idea is just to show you that although we have all these assays described, Vergene has also several capabilities that can support at level of function characterization all the pipeline in cell line development that you can integrate, not only at level of function characterization, but also at level of biophysical characterization, looking, for example, at level of characterization under non-stress conditions, or stability screenings, or even storage stability. In the end, once you have the cell line developed, we can produce the protein for you, in case you want it, or we can store your cell vials in our cold storage so that they are always there with us and ready to go whenever you need the production. Or in case you want, we can transfer them to you so that you can use it at your purpose. So as a last slide, just to show an overview of the things that you maybe do with us. So the idea is to provide you the ability to generate already stable cell lines for antigen production at level of the lead discovery setup, so that we can already have some tools for your discovery project, but also being able to generate stable cell lines that can also produce your already lead candidates. At the same time, I think it would be also important, and even more, is one of the things that is even seen every more, to start already cell line development earlier. So already in the time where we had doing the lead optimization, and you have several pre-candidates, so that we can gain time forward and just move with the ones that you need, already having the pools, for example, generated. Yeah. And thank you all for your attention.